software assurance. But let me tell you how I see it. It's good behavior under an umbrella that stitches together other disciplines. Well, take information assurance. I'm really an information security guy that just happens to have spent a life being a developer. It's not true for all information security people. So they have very much controls and rules they need to worry about. We have a list of controls called IA controls, the 8500.2. It actually, first half is boring reading, but there are a bunch of technical pieces in there. For example, if you're going to build a system and you're going to manage users, how you should store user account information and passwords, how do you manage them, how do you get them to show up, how do you get them to leave the account system, how are they triggered by a person leaving the role or responsibility, and what do I do about knowing the state of that person while they're under management, like has he logged in 30 days? Maybe I should idle out his password until he comes up and asks for it again. He hasn't touched it in 90 days, maybe he needs to be locked out. So there are rules like that. Well, wait a minute. If you guys are building systems that I'm the security guy for, wouldn't it be incumbent upon me to maybe tell you about that rule? So when you are designing it, you can make design decisions. Derived requirements from the IA controls that say, well, you know what, we were thinking about plopping this Java application on top of a Windows box. Why don't we just leverage the controls and the user accounts from within Windows and just make it a normal application, as opposed to making it like a kiosk mode where you log into our application, because then we don't have all this extra work to do. Perfect design decision. In some cases, maybe in other cases you have to do something different. So there's an example where software assurance, it might be best met by maybe systems engineering people and information assurance people talking to someone who actually writes code on the program, so together they make good design decisions. What we see a lot is this separation of roles where information security people are worried about firewalls and intrusion detection systems and antivirus and technical controls. All right, I have a graphic that moves this way. I said it before, but not really importantly, but it all really comes down to predictable execution. I want my programs to do what they're expected to do, what the user asked for it to do, and users with requirements are not always clear and they don't ask for all the things they want, or maybe they do, but it's not really the stuff they need. If you are the person making design decisions and implementation decisions, and writing code is an activity that is actual design at the point you're actually making the code, there's no one who's going to tell you a requirement so clear that you're just cutting code like a code monkey. When you're writing code, you're interpreting a requirement typically, and you're making good decisions based on what the language offers you or choices. You may not have the choice of what language to apply, maybe you do have a vote in that stuff, but when it comes to writing code, you're making design decisions. So it's about predictable execution. It's about the code doing what it should, regardless of whether or not the customer specifically said, well, I want it to process these kind of messages. Oh, I forgot to tell you, when it gets any message that isn't like those, please reject them. That almost smells like common sense. It's a robustness issue, an availability issue that a designer or a coder would probably code it the right way, but that always doesn't happen. So what we're focusing on now too, I notice, like I said before, that we often look at, they give requirements, we interact with the user, we build them, we look at policy, and we do what we need to do, and we test for what we need to test for, and we have those hurdles we have to hop over to get it out the door, either a deadline or a user acceptance or something like that. Commercial industry has the same thing. But like I said, there should be a set of things too that you should bring to the table saying, and here's how it should act when things are bad. So the use of lots of stuff available out there today, runtime analysis and fuzzers and things that actually distress your application, perfect stuff. Here's an example. Back when I went to school, there were dinosaurs roaming the ground, but my department head allowed me to do a small project on the side. I just was shy a couple credits to graduate. And he goes, okay, so, pitch something. And I pitched a little robot tethered to an Apple II, 1981. And that's what we built. And worked all the pieces, ready to present my end of quarter. And the first thing he did was ignore everything I said and start pounding on the keyboard. I almost freaked out. He's just pounding on the keyboard trying to make it do something wrong. That's exactly the kind of testing we should be doing sometimes. It is not what people expect. It's easy to test what we want. Here's a summary slide. Again, I'm just going to rehash all the same stuff. There are things we can do. There's a lot of big words here too. Threat modeling and analysis and requirements engineering and fail-safe. There are a lot of software engineering and software quality engineering stuff you'll probably learn. Now, moving forward, I'd like to tell you a little bit more about kind of what I'm doing and how we're applying some of these things and why they're important. Okay, I call it current progress, but it's really how things are happening today. Okay, I think you guys get it. There's a problem here. Software could be coded accidentally wrong. It could be on purpose wrong. And Lord knows we take these things and put them at places where it's exposed to risk. Everybody does. The internet's a great risk laboratory, a threat laboratory where I deploy software, see what people do to it. This is a software assurance problem, but it's part of a mission assurance problem in a general overall umbrella. And again, mission assurance, again, is a set of activities that integrate these pieces, not just for the purpose of software, but for the rest of the pieces too. There are significant risks across the life cycle. And we're working within, you guys have probably never heard this stuff. So everyone has a life cycle. We have one too. It's called the DoD 5000. And it's a set of phases where you decide and select and you build and implement and you deploy and run. You can pick any life cycle. It has phases. And there are lots of people trying to break this down into something that you have these phased set of developments where you're making sure your requirements are right before you cut code. You're implementing in a way that makes sense, and then you limited test it. And then you deploy it in a limited way, then open up to greater deployment. It's a staged set of things to do. But in our world, we also have this thing called DIACAP, and it has a subset of stuff we do for the Air Force called CISU. And it is exactly the security pieces specifically. Well, I forget the engineering part. There's a lot of parts there, but just focus on the security pieces for a second. Answer these questions. And that's what I spend my time in that space. And it's activities spread across the life cycle of that design and develop and deploy phase. Every day that we work, we make a case. We're like lawyers. We defend what these guys built on my program. If you guys are my developers, my job for like the IA person for your group, the information assurance person on your program, my job would be to make a case and defend why what we built is allowed to connect to the Air Force networks. That's my job. My job is to be working with you all along, so when I make that case, it withstands scrutiny, but in the end, near the end of the different phases, I'm defending a case, either through the design phase that you designed it right and here's why, or why we built it right and here's why. And that includes test data and methodologies or any kind of documentation that I can show that shows what we're doing. But what I don't have is actual arguments to make a case like a lawyer. Well, actually it is more like a lawyer. It's a subjective set of phrases with a guy waving his hands saying, this is good because of these reasons. And as long as it's a reasoned argument and it fits within like what smells right, it has a good chance of going forward. But it hasn't proven anything. The guy at the other end, the reviewer, the auditor at the other end, that says yes or no, I haven't given him something definitive to put his teeth around. So for those weaknesses that are listed, well, there's no listing of weaknesses, but if there was, then the paths to get to those weaknesses in your code, oh, I'm sorry, there's no way to measure those paths. If we had something like that, I can prove for the known weaknesses to things like this exposed to that kind of threat, and these pathways to get to it are impossible because I did these things and there's a measurable way of doing it. I don't have that available right now. And of course, even in our space, we work under the same pressures you do. There's my life cycle. The actual fun answer is farther down in the slides. I was almost going to put it right after this one, but I'll go through the boring stuff before I get to something fun. So this is the life cycle. This is what we see. And early, where before you would see something show up on the external page saying, here's a new aircraft we want to build, we have a request for information, or we have an RFP that says, please solicit your proposal. In there we have a technical requirements document. The neat thing about our world is that I can use these for purposes. That technical requirement document has sections on saying, well, when you show up and you want to propose something to build this aircraft, show me these things so I can make a better decision. You say that you're really good at development. Show me your CMMI level certification, or tell me about your development practices, or discuss how you will solve this security problem within the design that you've pitched. So these are neat opportunities for me, I'm thinking. Susan Sal's, where you actually, I think I'd pick you guys, Team A. I think I'll pick Team A. And Team A, okay, if you guys are going to build the design you pitched, then here's what I expect from you. And we work out expectations between each other. Sounds very much like a course I just saw. So the courses you're learning here at Purdue are actually really grounded in real-world activities. Right before we're done developing things, we're designing, we're thinking about what we're going to build. You pitch something in source selection that I said sounds good, but the practicality is that computing system is now end of life, you're going to use a different model. Okay, that's okay, as long as it has the features I wanted, right?